In the previous video, we created a relatively basic snow generator, similar to what you see on the screen now. The way that we did that was by creating a geometry script similar to this one. It might be slightly different because I've added some comments to this, but the way we did it was create a variable that allowed us to take in a number of meshes from the scene that we wanted to add snow to, and then we created a bounding volume hierarchy just to make it a little bit more efficient. And then we used Raycast to add spheres on top of those meshes that we want to add snow to. And then we took those spheres and we remeshed them using like a voxel-based system into a new mesh that we then smooth, apply UVs, tangents, and normals. We reposition it so that it's in the correct space in the world, and then we release all compute meshes just to make it a little bit more efficient in terms of memory. And that's basically what we created. In this video, what we're going to do is expand on that system, adding more features which allow it to create a more realistic snow, a little bit less cartoony. So let's get started. So first of all, to make the scene a little bit more complicated so that we can really challenge the snow generator script, what I've done is I've downloaded a asset from the Quixel Megascans library. This is the massive tundra rock formation. It is around 2 million triangles, so it's quite expensive in terms of polygons. So that'll help us test the efficiency of the tool as well. You'll notice I've scaled this down to about a quarter of its size. That is purely just to make the remeshing a little bit easier to use. In this version where I had scaled it down, I hadn't used the remesh tool enough. I now realize that there's a better way to do this, and I'll talk about that later. Okay, the next thing that you might notice is that we have an icon now. This is our snow generator script. So I'll just really quickly show you how you can add your own icon. So basically, if you go into your geometry script blueprint, then you can click this add button here, and then you can look for a billboard. And then if you click this, what it'll do is add a new subcomponent called a billboard. Now basically the billboard is just a way to add a sprite in the world. Just makes it a little bit easier to select your snow generator. I've literally just used an icon that was already in the engine, looked kind of like a cloud, and I've used that. But obviously you could create your own image and then use that. First thing we should probably do is try the snow generator that we created before on this new asset, and it's not going to produce a brilliant result, and this is what we're going to cover in this video on how to improve it. We've got our 2 million poly asset here. If we go to the add element and then we want to go down and select that object. Now because it's 2 million polys, this process is going to take some time, so I'll speed up the video and see how long it roughly took. So that's it generated, and it took about 30 or so seconds, which isn't too bad, but obviously it's not real time and it's not going to be very interactive. So performance is definitely an issue, but also the next issue is that it doesn't look great. There is not enough geometry for it to follow the shape very well. There's lots of different reasons for this, and as I say, that's what we're going to figure out in this video. So I think the first thing that would be good to do is try and improve the performance of this so that when we're making changes, it updates a bit more quickly. One thing you'll notice is if you try to make changes inside your snow generator script, each time you add, say, a node or do an edit, it will try to regenerate the snow. So what we want to do first is basically turn the snow generation off. So to do that, all we need to do is go to snow generation and untick this box. So the thing you need to understand about geometry script, and to be honest, any blueprint, is different nodes require a different amount of processing time. So one of the things with geometry script that's got a reasonably intense processing time is converting these meshes into the bounding volume hierarchy, especially when the meshes contain millions of polygons. This process takes a reasonable amount of time. The other thing is copying static meshes to dynamic meshes. But one way for us to make this a bit more efficient is to move the copying of the meshes and the bounding volume hierarchy generation to a separate process. The reason for doing that is that often when we're generating the snow, we've already decided which objects we want to generate the snow on. So the bounding volume hierarchy is not really changing each time we generate the snow. Unless we add more objects or take away objects, then it's basically staying the same. So moving this into a separate process will allow us to generate the snow more quickly because we won't need to regenerate this bounding volume hierarchy each time we want to regenerate the snow. So the way to do this is relatively straightforward. First we need to right click and look for a custom event. So we want to add a custom event and we want to give it a name, and I'll call this generate mesh cache. So basically that is going to be an event which generates the cache for generating the snow. And then what we want to do is go over here and say call an editor. Now there's a sort of bug, I would say, with this. You notice how currently the default, which is our variables, is at the top of the blueprint, which is how most blueprints work. However, when I click call an editor and then compile, this default gets shifted all the way down in the list. So if you find that you're struggling to find your variables after you've added this custom event, then be aware that it might have moved everything lower down in the list. You can obviously put these into groups, which will move some of them back up, but this custom event I don't think can be given a group, so it means it always sits in this default tab. In this particular geometry script blueprint that you use to get the onVent rebuild generated mesh node, it seems to not order them in the same way as some other blueprints do. So anyway, if you've lost your variables, then check where the default category is, and then you'll be able to find it. So what does this call an editor do? It basically adds a button here, which when we click, it will run anything that is connected to this custom event. So we can then generate our bounded volume hierarchy using this button, rather than when we change sliders and edit properties. So let's test that out and see how it works. So to do that, what we want to do is connect this up to our copying mesh section, and I'm going to move this up, and I'm going to take these 3 nodes, and I'm going to cut them out and paste them back in. Then I'm going to have to create another sequence node, so I can also copy and paste that. Now I'm going to connect this in. If you ever want to remove any, you can just right click and remove execution pin, and then I'm just going to connect these both up. So now what that's going to do is when I press the on generate mesh cache, it's going to run through and copy the meshes from our variable, and then it's going to create the bounded volume hierarchy for it. So let's just quickly test that out now, and you'll get an idea of how long that process actually takes. So we need to compile, and then we need to click generate mesh cache, and I'll speed up the video and come back when it's finished. So that again took maybe 25 seconds or so. Hopefully that should mean that when we finish this, we should be able to get a much more reactive tool. Let's quickly tidy this up and finish it off. Obviously, now that we've taken these sections out, no longer need to have this connected to this part, so we can basically right click and break links to pins. And then what we want to do is connect up our loop, which is basically doing our raycasts, and then we want to remove this execution pin. So now that we've connected that all up, what we want to do is test generating the snow and make sure it works. But I think we're going to find that it won't work, and I'll explain why in a second. So we need to re-enable generate snow. And as you can see, the actual blueprint fired, but we have no snow. Now it could be that the mesh cache is out of date or anything like that, but it's not actually because of that. If we go into our output log, what you'll see is the bounded volume hierarchy is invalid for this target mesh. If we try to generate the mesh cache, which I'll do now, you'll see that the mesh cache has now been generated, but even when we change these properties, we're still getting no snow. Now, why on earth is that? There's a couple of things we need to understand about this blueprint. One is that when you change a property here, it basically sort of reruns this whole blueprint. So it looks at all these variables, and what's actually happening is this bounded volume hierarchy is being cleared. There's lots of ways you can work around this, but the way that I do it, or the way I'm doing it currently, is that if I expose this variable and expose the raycast mesh actors variable, because we use the raycast mesh actors in the raycasting section, so we need to have those both exposed. We can then compile, and then when we go back to our blueprint, you'll notice that we now have a raycast mesh actors property. You'll notice there's no output BVH property. Now I think that's because this dynamic mesh actor is not a thing you can edit, so it won't be visible here, but behind the scenes it's now storing this in memory. Anyway, so the first thing we need to do is click generate the mesh cache. Now you'll see it's actually added data into this raycast mesh actors. So that's good, we know that this generate mesh cache has actually done something. Now if we try changing the sphere radius, we get snow generated. When we try and run it a second time, you'll notice that nothing's happening again. It's definitely firing, but we're not getting any actual snow, whereas it worked the first time. The reason for this is quite obvious when you think about it. We are releasing all compute meshes at the end, which is basically releasing the raycast mesh actors. So if you find that you're getting something that's happening, you don't understand why, it's always worth looking in the output log, because it'll usually explain what's happening. BVH is invalid for this target mesh, and that's because the raycast mesh actors is now empty, So when the bounding volume hierarchy is trying to do its testing, there's a discrepancy between this and this. So what we need to do to fix that is basically go down to this release all compute meshes and sort of remove that from the process. So we just break the link. So that is basically going to no longer release all the compute meshes, which might mean that some meshes build up in memory, which is something we will look into later. But for now, it allows us to get the script working again and test out how efficient this tool now is. So we need to compile. Now, because we've compiled, there's no longer any cache, so we need to generate the cache. So I sped up the video, but it took about 20 seconds or so. Now that we've done that, we can just change the property in here, and we should see spheres appearing on our mesh, which we do now. So if I put in 100, you can see it's quite responsive now. All the time that we're getting in terms of processing now is just doing the raycasts and positioning the spheres. So whereas before we might be waiting 30 seconds, we're now maybe waiting 5 seconds, depending on how many spheres we add. So if we add like 2,500 spheres, it's maybe taking about 5 to 6 seconds, which is a lot better than 30 seconds. Obviously, we're not generating the remesh at the moment, but we can also do that. And you can see, obviously, we've got serious problems with that, but for now, it doesn't matter. The principle is the same. It is producing the spheres and it is generating the mesh a lot more efficiently now. Okay, so now that that's working a little bit more efficiently, I'm going to turn off the generate snow so that we can edit the blueprint more quickly. So the next thing we want to look at is how we generate the raycast. This method where we use like random positions within a bounding box is good for creating like a stipply snow pattern, but it's not really great for efficiency because you end up with lots of spheres very close to each other, and then you end up with areas where there's very little spheres. Whereas when you see snow, it generally falls and you get like a blanket of snow. It literally looks like it's covering every surface. For now, let's try and recreate that blanket of snow look, and then we can always add in additional features to break that up. So the way that I'm actually going to do this is that rather than using the random position within the bounding box, I'm going to create a grid system where it's going to be like each raycast is going to be evenly spaced over a grid. And to make it a little bit quicker and easier to test, what I'm going to do is I'm going to hide this particular mesh. I'm going to add in a plane. It's just a simple 1 by 1 meter plane. Snow generator into details, and I'm going to remove that tundra mesh and I'm going to select the plane instead. Obviously we've changed the bounding volume hierarchy now, so we need to regenerate the mesh cache and then we need to generate snow. And I'm going to make the radius a bit smaller so we can see them, and I'm going to turn off remesh just so we can see. Now this gives you a good example of what I mean about the spheres sometimes grouping together. So you can see there's 3 spheres very close together here, but no spheres in this space here. So we're going to improve that. Is select all of the raycast stuff, and I'm going to move it over into a blank space just so it's easier for you to see, and it gives us some extra space to add nodes. So the first thing that we want is we do want the bounding box from the various meshes that we add to our tool. So that can remain. In fact, what I'm going to do is I'm going to keep this random version and basically select all these nodes, copy, and then I'm going to paste. I'm just going to paste it down there out of the way. And then I can go in here and I can remove the things that I don't need anymore. So I'm going to take those out. I won't need a random stream anymore because it's not going to be random. And then the next thing we want to do is start creating the maths to create this grid system. So what do I mean by a grid system? So this is just a quick image I got off Adobe stock, and just to explain what I'm going to try and do. If you look at all these points that's on this image, you've got evenly spaced points in a grid formation. So in order to do this, what we're going to do is find the point of the very first grid point, and then we're going to define a spacing amount, which will be in centimeters, from that point to the next point. And then we'll use that spacing amount again to place the next point and the next point and so on. And we're going to loop through until we hit the number that we need to fill the bounding box in one direction. Then we're going to move up 1 row and we're going to do that process again. And then we're going to move up another row and do the process again. And we're basically going to create a grid formation using this next series of nodes that we create. We could do this a number of different ways. We could define the amount of points we want in the X direction, amount of points we want in the Y direction. Or, like I was just saying in the section before, we could define the space between the points. You could use either. I personally prefer the idea of defining the space between the points. It allows it to be used more flexibly going forward. So the first thing we need to do is calculate the number of points that will be in the bounding box in one of the axes based on the grid space. So to do that, we're going to do a really simple piece of maths, which is we're going to subtract the maximum, so this is wrong, we'll subtract the maximum from the minimum, which is basically going to give us the distance of the x bounding box. So it's going to be the length of the x in the bounding box. Then what we'll do is we'll create a new variable that is called grid spacing, and we'll set it to a float because that allows us to have like 0.5 centimeters or 1.5 centimeters. So we'll get that, and then what we're going to do is divide the length by the grid spacing. Now this really simple piece of math, what it's going to do is get the length of the bounding box in the x direction, then we're going to divide it by the grid spacing. So if the x length of the bounding box was 100 centimeters and our grid spacing was 10, it would mean that we would divide 100 by 10, which would give us 10, which basically means we would need to place 10 spheres in order to create a grid spacing of 10. It might sound a little complicated, but once we actually get it running, I'm sure it'll be much easier to understand. I'm going to round this value. All the round node is rounds whatever comes in. So say it was 9.7. We obviously can't have 9.7 spheres. We need either 10 spheres or 9 spheres. So by rounding this, it will just allow us to have a full number, which will allow us to use our for loop. So once we've got our rounding, what we want to do is subtract. So basically what we're going to do is subtract 1. So when we connect it to the loop, we'll get 10 outputs, going from 0 to 9. Now that we've got the right number of times to go through the loop, we need to actually set up the maths to change the position. So what we're going to do is take the index and we're going to multiply it by the grid spacing amount. Now, if you think about this, what it's going to do, it's going to take the index, which will start off at 0, then it's going to multiply it by the grid spacing amount, which will come out the first time as 0. The second time, it'll come through, this index will now be 1, so this index will now be 1. It'll go in and it'll multiply it by a grid spacing amount, which will become, in our case, if this was 10, it would become 10. So basically that means that we will end up with our grid space moving 10 each time we run through this loop, which is what we want. But in order for us to get the right position, we also need to add the minimum bounding box position. And then we're going to go plus to add, and then we're going to connect this on. So now when we connect this into the ray origin, so what we're going to get is we're going to get the bounding box minimum x position, and we're going to add our grid spacing offset to that each time we run through this loop. What that should mean is that we'll have evenly spaced spheres in the x-axis. So in order to test this, we need to recompile and then test to see if the snow generates. One thing to bear in mind is since we've added the custom node to generate the mesh cache, each time we compile we need to regenerate the mesh cache, otherwise these like actors to add snow to will be nothing. So we generate the mesh cache and then we can regenerate the snow. Now you can see that we get our 10 spheres, but you can see there's one missing at the end. So if we would prefer that to have one at the end, then we can just remove this -1, compile that, and then generate the mesh cache, and then regenerate the snow. Now we have 11 spheres going from one side of the x minimum bounding box to the x maximum bounding box. So now that we've got that working in the x, we need to get it working in the y. Now the fastest way to do that would be to literally copy all of these nodes. Let's just align them better. And then we want to do the maximum y away from the minimum y. Now if we go back to our grid spacing diagram, what we've done now is we've created the first row. But each time we create a row, we need to move up in the y-axis one grid space, and then create another row, move up in y and create another row. Or you can move in the reverse and do like the y and then move across and do the next row of y. So that's what we basically need to do next. So to do that, we need to create another for loop. But this time the for loop is going to use the y-axis. So I'm just going to basically copy and paste this. Each time we move one space in the x, we're going to do a full row of the y. So I'm just literally going to connect this up to here. And then I'm going to move this out of the way. Let's put it down here. This gets a bit more messy when you're working blueprints. So just get a bit of blueprint tidy up. I'll speed this up. Okay, now that's a bit more tidied up. The next thing we need to do is basically add on the output from our y to the minimum y. So it's exactly the same as we did in the x, but this time we're going to use the y. So we get our index, and then we're going to multiply that by our grid space, which is exactly the same as this. And then we need to get the ymin, which is here, and we need to add what comes out of the loop. And then we connect that into our y. And then we connect the loop body into this. So it might seem a little complicated, but once you get used to what's happening, it's relatively straightforward. I can now get rid of this, just tidy it up a little. So what's happening is we're going to go in and we're going to get the first X position, and then we're going to assign that to our raycast. Then straight away after getting the first X, we're going to go in and we're going to get the first Y position, and we're going to assign that to our raycast. Then we're going to get the second Y position and assign it to our raycast, and the third, fourth, fifth, etc. And then when that's finished, it'll go back to this loop and it will get the second X position, and then it will repeat that process. So in theory, what we should have now is a complete grid from one corner to another. So we need to generate our mesh cache, and then we need to re-enable the snow. Now you can see we've got a perfectly spaced grid pattern. Now the cool thing about this now is that if we make this 5, then we get much more spheres. If we make it 50, say, then we only get very few spheres. So now we've got a system that basically can generate a large number of spheres. For example, if I put in one grid spacing, it's going to generate around 10,000. So we don't want that many because it's way too many. But like 2.5 is quite a good amount for coverage. You can basically see that we're getting very little of the plane visible. But obviously if we scale this up to like 2 meters or 4 meters, then we're going to get loads and loads of spheres. So the balance is really finding the right number for the amount of detail that you require. For this, let's drop it down to 5. The reason, if we use a radius of 2.5 for the sphere and a spacing of 5, then that means we end up with a perfectly full grid that's not too heavy in terms of the amount of spheres that we're actually using. Now that we've got that, we can add in additional actors. And then we can select our snow generator, and we can add these new meshes. So you can see that it's not doing anything because we've not regenerated the mesh cache. So we click that, and then we can turn on and off the snow. And now what you see we get is this perfect grid being wrapped around all of our objects. So one of the issues you might have noticed is that the spheres are generating on even very steep surfaces. So if I rotate this cube and then we select our spheres and generate the mesh bounded volume and then regenerate, we're still getting snow on this very steep surface. It's not really something we would want. The snow would probably slide down and end up on the lower surface. Now we're not going to do layer build-ups on this video, but I have done a version that has that, so I might show that at a later date. But for now, we do want to get rid of the snow off the sides based on the angle of the surface. So in order to do that, it's relatively straightforward. When our ray hits our object, we actually get a whole bunch of parameters being fed back. So one of the parameters is the triangle ID. If we drag off that and search for get tri, you can get the face normal from the triangle. All we need to do is add in our mesh, which is our ray mesh actors, because that's what we're testing the raycast against. So that's the triangle ID that we're going to get. And then from that we get the normal of that particular triangle. So if we split this apart, then we've got the Z, so if you imagine the faces on the sphere, for example, any faces at the very top will be 1 in the Z because they're pointing directly upwards. But as we slowly tend round, these are going to become closer to 0. So this might be like 0.5, and this 0.6, 0.7, 0.8, 0.9. So what we need to do is test whether the Z value is greater than or equal to, a number. So what I've done is I've created this snow coverage variable. So just click plus and then set it to a float and then named it snow coverage. So I'm going to get the snow coverage. Now if we connect this up and then we create a branch, which is basically an if statement. So it's going to go, if the Z normal is greater than this value, then that's true. add on the sphere or it won't based on this value here. So then we can compile, and then we can generate the mesh cache, and then we can regenerate the snow. Now you can see I've got 0.6 in the value at the minute. If I put 1, then we get no spheres on any of the surface because all these are above 1. If we go 0.5, then we start getting them down to the sort of mid of the sphere. 0.4, we get some more, 0.3, we get some more, and so on. But this isn't quite right because this is called snow coverage, and we're saying that 0.3 snow coverage is more than 1. 1 would be like the thing covered in snow, and 0.3 should be the thing with less snow. So it's inverted at the moment. So in order to fix that, we can do some really simple maths, which would be to subtract 1. And then we basically want to use a node called an absolute. So all an absolute float does is it returns the positive value of a. So if this comes, so if we go here and say this is set, so it's set to 0.5 and we take away 1, then we get minus 0.5. But we don't want minus 0.5, we want 0.5. So we use the abs node to basically invert that minus to a positive. So if we compile that, and now we try to generate our mesh cache and then regenerate our spheres. Now what we should see as we lower this value, we get less and less coverage, which is correct. That's what we want to happen. So this is now working. That basically just allows a bit more control over where the snow will actually appear on the various objects. So after creating more of the tutorial, I decided to sort of add an additional bit into this section because I realized that the way we calculated the snow coverage in this video, I found it didn't work as well as a version I'd done ages ago in my own time. And although technically the version I'd done in my own time is less accurate in terms of the way it calculates what face is pointing upwards, I felt it was worth mentioning because you might find that you prefer the results you get from one or the other method. Basically, the way to set this up is if you drag off the make vector and look for equals and choose the one under operator equal, not these ones, this one, what this particular node does is it compares one vector, which is this, which is the direction of our face, with another vector. And if we put 1 in here, then what we're basically saying is compare this vector with a vector that points directly upwards. So it's very similar to this, but the difference being it considers x and y, which technically is incorrect, but I've found that it gives some quite nice results sometimes, so I'm going to keep it. I'm going to copy and paste the snow coverage and put it into here. Now the value at the bottom is basically an error of tolerance, so it's how close this direction is to this direction. So the higher the value, the more it will allow for the directions to be slightly different. And the lower the value, the closer it needs to be pointing directly up. So that is basically doing a very similar thing to this greater than equals to node, but it's doing it based on all 3 axes rather than just the Z. So as I say, it's not as accurate in terms of in theory, but I found the results can be quite interesting. So as you'll notice here, I've already created a new Boolean variable by clicking add and then filling in the properties. That's basically just saying use alt snow normal method. I'm going to expose that so we can see it in the editor. And what we're going to do to make this all work is we're going to drag this in, create a branch, and then what we're going to have is a branch right at the beginning that basically says which method do we want to use. And then I'm going to create another branch, and this will be connected to this. So basically it's exactly the same as the way this works, but this is with our different alternate method. Now I actually prefer this method, so I'm going to put this as a default method, but obviously that's up to you, you can swap these around. So use alternate method. So when it's false, it will be this method, and when it's true, it will be this method. So then we can put this in as true. So basically it's doing exactly the same thing, which is going, if the direction of the face is close enough to the direction of this face, then it will add a sphere. And this one is doing a similar thing, but it's based on the Z normal only. And that's all you basically need to do. If you compile that, I'm going to move this variable quickly. Actually, I'm going to quickly rename this because really it should be called alt snow coverage method. So I'm going to compile that and I'm going to set it to be off as default. So it's not going to use the alternate one, it's going to use this one, the new one that we've just created. So I thought I'd show a very quick demo of the 2 different methods. So the first method, this one, which is our new method. So this is this method here, the one we just created. Now I'll quickly show you the old method. And this is the original method, this one here. One thing to bear in mind is that the coverage value used between these two different methods will provide completely different results because of the way it calculates the normals. So when I showed the first method, the one before this one, I used the 0.6 in coverage, but for this one, which is using this section, I used the 0.2. So I just wanted to show a different way, and I wanted to show how you can really easily add additional things into the node graph and make quite significant changes to the way things look. So I've decided to go back to the old Tundra mesh just to try out the new grid spacing on this particular mesh, and it will highlight some issues. So you can see here that's the snow that's been generated. It still looks really low res and kind of not really conforming to the surface very well. Obviously we can improve that by reducing the snow coverage amount. You will notice that it takes quite a bit more time now to process, and that is obviously because we're generating a lot more spheres, because we have spheres being generated for this larger mesh, and we've got a grid spacing currently of 10. Of course we could reduce or increase the grid spacing amount to make this faster, but for now that's fine. We can try and improve the speed later on. But the real issue that I want to sort of try to resolve is how the remesh isn't really high resolution enough. I'm going to just turn off generate snow so that we can edit the blueprint more easily. So there's lots of options inside this or mesh morphology node. One of the ones that we want to use is the grid cell size. Now currently it's set to use the grid resolution, which is this value here, but I want to change this to be the grid cell size, because I'd rather use like a value of centimeters rather than like an arbitrary number of like the grid resolution, which doesn't really relate to the scene itself. So I'm going to promote this to a variable, and I'm going to call it grid cell size, and then I will make that visible in the editor. And I'm going to compile that. I'm going to change this value to be a bit higher, because at 0.5 is half a centimeter, so it is incredibly small. But let's say we set it to 5 for now, which is 1 every 5 centimeters. And then we'll compile. Generate the mesh cache, which is going to take a minute, so I'll speed it up. Okay, that's the generated mesh cache. Then we're going to enable the remesh, and we're going to regenerate the snow, which will take a second. So instantly you can see that it's done a much better job of creating the snow. Obviously snow looks way too thick and a bit crazy, but that is a good start for us. If we reduce this down to say, I'm just going to turn off the generation, otherwise each time I edit this, it's going to try and regenerate. It's going to reduce the sphere size to 3. I'm going to reduce the snow thickness also to 3, and then I'm going to regenerate that snow. So now you can see we're getting something that's starting to look a bit more like snow. Obviously it's not perfect, we've got some gaps and holes and things like that, but for now that's a reasonably good result. I'm just going to quickly explain one thing. So if I go into the snow generator and the details, and currently the grid cell size is every 5 centimeters. So if you actually have a look at the wireframe, then you can kind of see the size. You know, like each of these is going to be roughly around 5 centimeters. Obviously when it gets to complicated shapes, it gets a bit more squashed. But in general, you can see that these are sort of evenly spaced every 5 centimeters. So if we were to go, okay, what about if we made it 2.5 centimeters and then regenerate it? You'll see that these will get smaller, but there'll be a limit to how small these will go. And there's a reason for that, and I just want to regenerate this to show you. You'll find that it takes longer, obviously, the smaller you make this value, because it has to generate many more voxels in order for it to actually generate this mesh. So now you can see that it's generated a much smaller, more dense mesh, and that is almost every 2.5 centimeters. If you go to the output log, you might see that there is actually an error popping up, which is saying the requested cell size will require significant memory and computation, clamping to 256 cells. Use cvar geometry script allow unclamped dimensions to disable this limit. Basically what this is saying is, in order to generate the voxels for this size of voxel, i.e. each voxel is 2.5 centimeters square, it will require so many voxels. The engine has actually told the node not to go beyond a certain number. You can disable this using this geometry script allow. and then you go into your command line and paste that in and press enter, you'll see that it's set to false currently. But if we were to change that to 1, now it's set to true, which will basically allow us to generate any size of voxel. You have to be very careful with this. You could end up with millions and millions and millions of voxels being generated, and this could literally crash your editor, possibly your computer, your graphics card. So just be very careful with this. Obviously you can change this because Unreal obviously sets it to a value it thinks is going to work for most computers, and your computer might allow for this to be a smaller voxel size, but the generation time will take longer, the memory amount will be higher, so all these things need to be considered. But if you do want to push it to the limits, you can change this value. Just be very careful that you don't crash your editor or your computer. So one of the issues with the snow is that it's a bit thick. Now we originally use, and we will still continue to use, but the snow thickness value to adjust the thickness of the snow. But we also kind of need to change the sphere, because if we have the grid spacing at like 5 centimeters, then we have a sphere at 2.5 centimeters for its radius, which will basically fill the 5 centimeters. It means that it's also 2.5 centimeters high, which means we can't have a thinner than 2.5 centimeter deep snow. We might want to have 1 centimeter deep or 1.5. So this is an issue by using the sphere radius only. So what we actually want to do is be able to squash the sphere. Now we can't change the sphere radius to be different on one axis, but what we can do is change its scale. So there's a couple of things we need to do to get this to work. The first is that when we get the angle of the surface of the triangle and the normal here, I want to make the sphere rotated so that when we squash it, it will align flatly on top of that face. So it's a relatively easy thing to do. We can just create, make a vector. So make vector, and we just basically connect in all of the surface normal. Then once you've got a directional vector, you can make a rotation from that. So if you go rot, and then you can choose, and we want to make a rotation from Z, which is the Z normal, which is the normal that points directly out the face upwards. So I'm going to select that, and then I'm going to connect that into the rotation transform. So that's good. That means that now our spheres will be rotated to align with the normal of the face that the raycast has hit. Next, what we need to do is split this pin, and what we want to do is promote the Z value to a variable. So promote to variable, and we'll call it snow sphere scale. And then we will enable that. And we will compile, and then I'm gonna turn off remesh. I'm gonna increase the spacing a bit to like 20, just so it generates it faster. I'm gonna generate the mesh cache, it's gonna take a minute, and then I'm gonna regenerate the snow. So cool, now we can see that the spheres are all being generated in the correct locations. So what we should be able to do now is go to our sphere scale and lower this value. If we lower this value, what we should get is like flat disks. Now that means when we generate the snow will be of a thin height. You'll notice that some of them are at odd angles, but you've got to remember it's hitting a face, and because there's so many polygons, this might create a bit of an unusual situation. But for now it's fine. So let's say we set the sphere scale to like 0.3, which gives them a little bit of fatness. And then we maybe cover this grid spacing down to like 5. This is going to take a while to generate because it's now generating a lot of spheres. So there you can see that we got something that's starting to look a lot more like snow. I still think that the amount of coverage is too high, so I'm going to also change the snow coverage to maybe 0.2 and see what that does. Yeah, so maybe that's a bit better. So one thing you probably noticed is that the variables are not in a very nice order, and things are all kind of jumbled up in amongst different areas and things. So like snow thickness is next to smoothness iterations, which doesn't really make much sense in terms of usability. So one thing you can do with variables is you can put them into groups. So for example, if we were to select the snow sphere scale, and when we go into the category, we can name this, like, let's just call it snow for now. So then we can decide what we would like to go in the snow category. So one of them would be like the sphere radius. I'm going to rename that snow sphere radius, just so there's some consistency. So snow sphere radius, snow sphere scale. Then we probably want to select the snow thickness and give this remesh category, because snow thickness will not do anything unless the mesh is actually remeshed. So we're also going to add in the remesh variable into there. We also should add in the smoothness iterations. That's another thing which requires the remeshing to happen. So the cool thing about this is the order you put them in here will also show up here. So I'm just going to quickly add a few more things. So I'm going to name this as to working. That's basically like, these are just things which we need because they're like working variables. We need them to do the work. The number of spheres and the stream are no longer needed, so we can delete those. It will say it's in use, and that's because I have a copy of those down here. But for now, I'm just going to delete that because I don't really want to do the random thing. And then I can delete the number of spheres and delete the stream and compile that. Now, when you go over to your properties, you'll see that we have a snow category, and inside that we have generate snow, spacing, snow coverage, radius, and scale. Then we have the remesh, which has got the snow thickness, the iterations, and the grid cell size. I think I'd like to move the grid cell size up to the top. Then we have a working category, which has the remesh actors and the output BVH. But you will notice that the generate mesh button doesn't go in the same area, which is kind of annoying, and I'm hoping at some point that might change. Because it'd be useful to either put in a category or be able to move this higher up, maybe to the very top. To be honest, I think default would be good if it was right at the top. So yeah, it's just something that you should bear in mind, and it's really good to keep this neat and tidy. So as you saw in a few steps back, when we were generating the snow, we were getting some slightly odd issues where there wasn't a good snow coverage on some pieces because of the angle of the face that this raycast hits. Now this is unfortunately just the nature of the way this works, and you could come up with a different method, and I might do another video on another method for getting the faces. But what you can do is, with most Megascans assets, or most assets in general, usually have LODs or some sort of lower resolution version. So obviously in this scene, I actually have another version of the rock formation. So if I enable that, I need to unhide it 1 second, and then I hide the bigger one. What we have here is effectively a much lower resolution version of that tundra mesh, which looks odd, and you might think, well, why would you want to use that? But there's a couple of reasons. One, because it processes much more quickly. If you have a full 2 million poly mesh, it's going to take a lot of time to do the cache. Obviously we'll need to do that once, but it's still time consuming. And the other reason is because now the faces are a bit larger. When we do a raycast, the chances are that we will hit more of these faces and get a consistent, smoother snow. So I'll just show you how that looks if we use this instead of this. So we go into our snow generator, and then we go to our top section, and we go into the meshes. And we can then find the second one, which is called low. So I can select that. And then I can go down here and generate my cache, which happens really quickly now because it's a much lower resolution mesh. Then I can generate snow. And now you can see it didn't run any faster, generating snow, because the cost is the same regardless of how many triangles there are, because we're using that BVH. But you can see it's giving us a much more consistently covered look. So now we can increase the snow coverage value, let's say 0.3. And we're getting something that looks a lot more like snow, and a lot more consistent. So once we remesh that now, I'm going to put this remesh grid cell size up a bit bigger, because I don't think we need it to be quite as small as 3 for this particular version. And then I'm going to remesh that. We get something that starts to look relatively good in terms of snow. I mean, obviously it's not perfect, and we could tweak the values more to make it a lot better, but it's definitely a good starting point. Now all we need to do is go in and select the low resolution one, which is this one. Go into details, scroll all the way down, and just hide actor in game, or make it invisible the whole time. It's up to you. If you hide it in game, when you press G it will appear, but it will be hidden when you press G again. So I'll keep it that way for now, but you could easily just turn off visibility altogether. And then you can go back to this and enable the higher resolution version. And you can see now that we're getting a sort of nicer, sort of more fresh snow look So that's something to consider. You could use a more dense mesh, like I'm using like, I think it's the third LOD or something, but you could use the second LOD or the first LOD, and you might end up with a better result. You don't have to do this. You can use the full 2 million poly mesh. So now that we've got some snow that looks reasonably interesting, let's start looking at how we can add more detail to that snow. So what we're going to do is we're actually going to initially use a displacement texture map to displace this snow. So first thing I'm going to do is like drag a space so I can add this in. And then what I'm going to do is right click and search for displace and apply displace from texture map. So it's really straightforward, does exactly what you think it would. Just going to move this. If you hold control, you can drag connections, and then I'm going to connect that up. So after it's done the remesh, it's then going to do this. But I actually want this only to happen if a remesh actually happens. So I can easily add this same if statement in here, and it just means that it'll only do this displacement if the remesh has already been completed. The next thing we need to do is put our target mesh into the target mesh slot, and we need to create a variable for our texture. So if you right click and promote to variable, and I'm just going to rename this displacement texture. So we want to right click and split the strut pins so that we can see all the different options that we have. So the displacement magnitude is simple. It's basically the displacement height. So we're going to change that to displacement amount. Let's call that amount. And the center is actually useful. It's just the center point of the displacement. So if it was 0.5, that means that it will push upwards and downwards by an equal amount. But if we set to 0.4, then it would push upwards less or more. So it's useful to have that as a variable as well. The last thing that I think we should enable is the image channel. Now, when you're using megascans, often the displacement's in the red or the blue channel. So it's useful to have the ability to change the image channel that you want to use the displacement from. Now we want to make all of these visible inside the editor, and then we're going to select these, and we're going to call this displacement, just so that we can have them all inside their own little category. And then compile. Because we compiled, we need to regenerate the mesh cache. So we've done that, and then we can toggle this on and off. And after a minute, we should get some snow across the whole surface of these rocks, which we do. And then all we need to do now is actually set up some of these displacement things. So inside my content drawer, I actually have a whole bunch of megascans which I've downloaded surfaces from. So let's pick something that's really obvious. So I'm going to pick the trampled snow because it's quite a distinctive displacement. Before I do that, I'm going to turn snow generation off because otherwise it's going to regenerate every time that I change this. I'm going to put the displacement now up to like something really crazy, like 25. Let's do 30 just for the sake of it. Now we need to choose a channel. So 0 would be red, 1 would be green, and 2 would be blue. I know that in these textures, the displacement is in the blue channel. You can check that by double clicking your texture and then looking for the height map. So that's what we need to use channel 2 for. Once we've got all this set up, then we can generate the snow. Okay, so it has done something, but obviously it's not very easy to see at the moment. Now, the reason for that is really simple. We've not regenerated our normals or our tangents. So although the vertices have been displaced, the actual shape isn't being shown. So it's very easy to fix. I'm just going to turn generate snow off, and then I'm going to open up the geometry script. So what I need to do is take these two nodes, the compute tangent and compute normals, and I'm going to copy and paste them after the displacement, which currently means that we're actually going to be doing this twice, which we don't want, but just for now I'm going to quickly do that, and I'm going to make this 90 because I want it to be completely smooth. And that is about it. So I'm going to compile that, and then I'm going to regenerate the snow. Okay, so now you can see that we are getting some nice sort of undulations and bumps and things, but it is pretty low res, and that is because when we look at the wireframe, our voxelized mesh is relatively low resolution. So that's a problem that we need to fix, and we will fix that in the next step. So we're back inside our geometry strip blueprint. I'm just going to move all of this over slightly. I'm going to rearrange this later, but for now I'm just going to move this over. What we want to do is, once we've done our remesh, we then want to subdivide the mesh so we get more polygons in between. We get more subdivided than we have currently. Rather than trying to remesh at a really low value, which will take a really long time, what we can do is remesh at a higher value and then use subdivision to make the polygons smaller or make the polygons more dense. So the way to do that is to right click and search for PN tessellation. So it's called tessellation, but really it's like subdivisions. I think PN is the type of subdivision that it uses. And we need to put our target mesh in, so we go to our working variables and drop in our target mesh, which is our target mesh. If we right click here, we can see the various options that we've got. So we've got an option to recompute normals, which is cool. And then we have the tessellation level, which is basically how much it subdivides. So I'm going to right click, promote that to variable and call it subdivision length. And then I'm going to expose that variable so we can see it in the editor. Compile. Okay, then we go back to the editor. Before we regenerate the snow, we need to generate the cache, which we've done. Regenerate the snow. So now you can see the result that we're getting. We're getting a lot more detail now. It's definitely not perfect, but it's getting better. So we can select the snow and we can increase the number of subdivisions. Actually, subdivision amount's in the wrong place. So I'm just going to stop the snow generation. And then what I'm going to do is move the subdivision into the remesh category. The reason for this is I think that we should have the mesh being able to be subdivided regardless of whether we use a displacement texture. So I'm actually going to move this up to after the remesh function. We don't want to do subdivision if we've not remeshed, because that would just subdivide the spheres and we don't really want to subdivide the spheres. What we want to do is if we use a remesh, then we want to be able to subdivide that remesh, and then once we're happy with the amount of polygons that we have, we want to be able to then displace that. So I think that works in a better way. And a lot of time when you're doing these type of things, you will be moving sections around to try and find the best place for where it should be. For now, I think that's a good location. I think putting this in here makes a bit of sense, but later on I might decide to change it, but for now that's fine. So I'm going to compile, close this, and I'm going to generate the mesh cache, I'm going to generate the snow, and then see the result that we get. Okay, that's pretty much what we had before, which is great. Now let's try it with 5 subdivisions instead of 3. So you can see that's given us even a little bit more detail, which is kind of cool. But one thing you might have noticed is that it looks kind of stretched or squashed. Now the reason, if I was to select this and go back to its default value, yeah, so I've gone back to default value and instantly you can see that these squares should be square but they're rectangular. Now the reason for this is due to the UVs. So the way we're generating the UVs currently is not ideal. So I'm just going to go in and quickly fix that. There's 2 things that I would like to do that will help resolve this issue. The first is that what we're using is the mesh bounding box, and we're taking its minimum values in the X, Y, and Z and using those to create our UVs. So basically what we're doing is, even though this is a rectangle, we are stretching this to take up the full UV space, which ends up meaning that we distort the shape. So we don't actually want to do that. What we want to do is just find the biggest value in the X or the Y and then use that for all the sides, which will mean we get UVs which are square rather than rectangular. So I'm just going to show you how you can do that. So if we break the link to the pin and then split the strut pin, and then what we can do is go max float, and then we compare the X and the Y, and then we split this and we just basically have it go into all 3 values. So what this node does is it returns a maximum value of A or B. So if X was 5 and Y was 10, then it would return 10. If X was 15 and Y was 7, it would return 15 because now X is larger. So that's all it does. Now when it comes out, we're going to make a box which is 15 by 15 by 15 if it was 15. So let's compile that and see the result. So we need to generate the mesh cache and then we need to regenerate the snow. Now that you can see, we're getting a perfect square rather than a rectangle, which we had before. So that's one quick way to fix this. One thing I do want to talk about a little while we're on this subject is we're using a box projection, which basically means that what it does is it takes all the faces which point upwards like this and creates UVs for those, creates all the faces that point sideways on and creates UVs for those. Same for the front, the back, etc. But what that can mean is that you get what is effectively like, you can see it here, you get bits where are pushing up, but bits where it's kind of pushing out. It creates like seams. Basically, they're UV seams. So it's almost impossible to have it where you're not going to have any seams. And we really want it to be as seamless as possible because this is going to create problems. Like a good example of it is here. You can see where this is obviously using a different UV from this piece and it's getting stretched. So I've done a lot of tests and fundamentally what I found was the best one to use and the simplest one to use was actually a planar projection. So we project straight down because when you think about it, all of our spheres are getting sort of placed from the straight down perspective. So the only issue with doing a planar is that you'll get some stretching on the edges. But I think it's more preferable than having these bits that stick out randomly like that. So I'm just going to quickly change that and show you what it looks like. And I'm going to compile, close that, generate the cache, regenerate the snow. So now you can see that we've got rid of that extrusion problem and we've got more of a tiny bit of stretching. Before moving on, I just want to show one more thing. So obviously that we've now fixed the UVs, but one thing that can really improve the look of the snow is actually adding the snow material to it. So I've created a really basic trampled snow material that is created a custom massive material, and I can maybe cover this in another video, but all it has is the Megascans diffuse or albedo and the normal from the Megascans. Then we have the ability to tile it in the U or the V. The next thing we've got is some sparkling things, which creates this sort of sparkling effect. As I say, I'm not going to go into this, but basically all I'm using is the diffuse or albedo and the normal map, and then I've got a flatness value which allows me to remove or add the normal map. So I'm just going to apply that to this mesh, and you'll see the difference it makes in a second. So that's loaded on. Now if I put this over to the side, I can toggle the normal map off. So that's without the normal, and that's with the normal. So you can see it adds quite a nice additional bit of detail to this mesh. It just basically fills the gaps between the various polygons. And we could obviously do that by adding way more subdivisions into this mesh, but I mean obviously there's a benefit to doing that. In some cases there's not. You know, we're still getting nice silhouettes, but we're not needing to have a mesh that has billions of polygons in it. So you know, it's always like everything in game art, it's a trade-off. You know, you've got to find the right settings for the thing that you're making. So one of the cool things about using the displacement texture is we can really quickly change that to a different version. So I'm going to select this one and drop that into the displacement texture. It'll take a minute for it to regenerate. But there you can see we've completely changed the look now. The only thing we need to do is update the material. So I've made a snow material for this one, which is this one. And then when you zoom in, you should be able to see that this actually lines up with the bulges in the snow. One thing I'd say about this particular displacement, it probably needs a bit more height in it, and it also needs to be tiled more. So we'll have a look at tiling, having options for being able to tile more or less in the next section. So as I said just before, what we're going to do now is try and tile and offset our UVs using some variables. But before we do that, I just want to quickly explain why we would want to do this. So if I go into the top view, I've created this really simple scene just to explain. It's basically exactly what our UVs are doing. They're planar projecting straight down onto our mesh. The mesh is the green thing and our UVs is the yellow box. So as you can see, basically what is happening is our model is getting mapped to fill the UV space based on its largest axis. So in our case, the largest axis would be its x-axis. So it takes that axis size and then tries to fit this model into the UVs using that axis. The problem with this is, obviously, depending on the size of this model. Say this model is 20 meters across by 10 meters. If we open up our texture, and this is just a normal map, it doesn't matter which texture, but if you imagine that texture is mapped to that square, then what it means is from this point on the model, which is the left-hand side, all the way across to the right-hand side, we're going to be using the texture from this side to this side. So it means basically our model is all the way across this texture. Now, if you imagine a footprint like this, this footprint might be, I don't know, 20, 25 centimeters in its length. But if we imagine this object 10 meters across this way and 20 meters across this way, then this footprint is going to be, I don't know, equivalent to 2 meters or something. It's going to be absolutely massive. So what we need to be able to do is tile our displacement calculations and also our material. Now, normally what you'd do is you just go into your material and you would edit the tiling. The problem with doing that is that if you create a displacement, which is based on these UVs, and then you modify your material to be more tiled, then the displacement in the material normal maps are no longer going to align. And you can have that choice still. There'll still be a choice to be able to choose whether your UVs align or whether they do not between your displacement and your material. But initially what I'd like to do is like add the functionality to be able to tile these UVs directly on the model rather than doing it in the material. So hopefully that explains why we're going to do this. So I'm back inside the geometry script blueprint, and to add our UV offsets and scaling, what we are going to do is go into the remesh section. What I'm going to do is I'm going to do it before the tessellation because it should make it run a little bit more quickly. It would be possible to do all of this inside planar projection, but I personally find it easier to do it this way. Again, it really comes down to how you want to approach it, but for this we're going to use 2 new nodes. So what I'm going to do is right click and then search for scale mesh UVs. So basically all this node does is basically what it sounds, is it scales the UVs of the mesh. So what we want to do is obviously connect in our target mesh, which is our dynamic mesh that we're generating, and then we need to give it the UV set number, but we're basically using UV set 0. But if you do want to use a different UV set, you can change that in here and then change it in here. Then you want to tell it where the origin is going to be. So this is the origin within the UV window. So if you imagine the UV window is a square, if it was 0, 0, it'd be at the bottom corner. If it's 0.5, 0.5 will be in the middle. If it's 1, 1, it'll be in the top right hand corner. So for ease, I'm just going to set this to the middle. So it means that it's scaling from the center. You could potentially promote this to a variable if you want it as a choice, but I don't generally find that I need to have that. Then I'm going to right click here and promote this to a variable, and this is basically going to be the scale or the tiling of our UVs. We want to call this UV scale, and we want to compile that and set this default value to 1, because otherwise if we leave it at 0, then our UVs will get squashed down to a tiny point. If we want to tile it 2 times, then we would set these to 2 and 2, but we can do that inside the blueprint itself in the editor. And that's really all you need to do for this. You basically just need to set that node up. And then while we're here, we're going to do another one, which is, so if you drag up here and search for translate, then you should see a translate mesh UVs. And obviously translate is just similar to move, so it just offsets the UVs. So again, much like we did in this one, we literally just connect everything up, right click, promote to variable, and then we can call this UV offset. I've broken my naming convention, so I'm going to quickly fix that by removing these underscores. We will quickly tidy that up. And for the scaling or the tiling and the offset, that's basically all you need to do. So then all we need to do is connect up the subdivision again so that we still subdivide our triangles. And you can obviously daisy chain this in here if you prefer, whatever way around you want to do it. So once we've set up the scale mesh UVs and set up the translate mesh UVs, all we need to do is enable the UV scale variable to be visible in the editor and also the UV offset to be visible. I've also added them into the remesh group. Ideally, we'd probably create our own UV group, but for now, it's fine to be in the remesh. Click compile, select our geometry script, go to details. I'm going to pin this. And then I've set up some numbers in the variables already, but obviously you can copy these. I basically put the tiling up to 2.5 on both axes. So it's going to be tiled 2.5 times in each direction. I've not offset the UVs, but you can do that later. And I've changed some of the sizes of the spheres and things like that. And then I'm going to generate the mesh cache, and then I'm going to generate the snow, and I'll come back once it's finished. So that's the snow generated, and now you can see that we're getting a lot more detail than we had before. You know, our normal map and our deformation, our displacement all match, and we're getting some stretching. It's just because the size of the displacement is too high. But in general, like, we're getting a reasonable result. Again, it might not be the right style of snow for what you want, but it's working in terms of a tool. Obviously it needs a lot more refinement, but it does what we need it to for now. The only thing I was going to say, and I wasn't sure where to put this in the video, basically at the minute we've got our snow, which is like deforming above the surface of our mesh. That gives us a nice silhouette, you know, which you can make out, you know, it's breaking up the silhouette. But when snow falls, obviously it lands in cracks and things, and it doesn't form like you know, a huge layer of snow in these little cracks on the surface, and obviously you get frost and things like that. So one thing you can do to sort of further improve this look is to add a material which uses like the Z up, similar to what we did in our script, similar to this, but in the material itself. And when the face of the object is pointing upwards, you apply like a white snow to it. Now there's loads of tutorials on the internet that explain how to make materials like these, so I won't cover it in this video, but I will show you what the effect is like to have that on the object as well. So the benefit of adding this is it just helps bridge the gap between the snow object and the rock surface. So I definitely think it's worth having something like this. It just really helps improve the look. I'm not saying this is perfect, it's far from it. I need to tweak the settings more and things like that to get it to look better. But it does help a lot to have the rocks have a more frosty look to them, and you know, we get a better sort of overall snowy feel to the whole scene and whole object. We've used a displacement texture to generate like a slightly more realistic looking snow. Obviously, depending on the texture used, the quality and style of snow will completely change. But what if you didn't want to use textures? What if you wanted this to be completely procedural? Now, I'm not going to go into detail on this, but I'm going to show how you would set up a basic version of that. Also, you can actually layer this extra layer of noise, which is what it's effectively going to be, on top of your displacement texture to even add even more detail. So I'm just going to show how you'd go about that. It's relatively easy, so shouldn't be too difficult. So we're going to go into our geometry script again, and we're going to take these two nodes and we're going to move them. So what we need to do is search for Perlin noise, which is basically a type of noise. So I'm going to select that, which is apply Perlin noise to mesh. Now, I'm not going to connect this target mesh in here like a daisy chain. I'm actually going to drag in the variable. I will explain why shortly, but let's just start by getting that variable in here and attaching that. Then we're going to split the strut pin of the options, and then we need to split it again because there's two struts inside this. And basically we'll get an idea of what's available to us here. So we've got the base layer magnitude. Now that is basically the height of the noise. Then we have the frequency, which is how large or small the noise will be. So we basically want to promote both these to variables. So we'll select this one first. So once we've added that variable, we need to name it. So I'm going to call this noise base intensity. And I'll explain why I've called it base in a moment. And then I'm going to also promote the second one to a variable, and I'm going to call it noise base frequency. And then I'm going to select them all, and I'm going to press Q, which will align all the nodes, and Shift D to align these. And that's basically all I'm going to do for this. The reason why I called it base is that we're going to copy and paste this several times, because the thing with noise is, in order for noise to look good or interesting, you generally need several layers of noise. And as far as I'm aware, I couldn't figure out how to add multiple layers in one node, so it feels like I have to have several nodes, each one providing their own noise at different frequencies and different magnitudes. So I'm going to connect this up, And I'm going to copy it, and I'm going to paste it, and I'm going to connect that up again. Because these are all part of the same thing, I can daisy chain them, so I can get rid of this target mesh. And then I'm going to copy and paste it one last time. So we're going to have 3 layers of noise. Obviously at the moment, these all use the same variable, so they'll all be creating exactly the same noise. So we need to change that. So we're going to delete these variables, and then we're going to right click each of these and create a variable for it on each layer. So I'm going to do this, and then I'll come back once it's done. Okay, so we've got our 3 layers. We've got our base, our mid, and our top layer. So basically each of these are going to be a different noise that's applied to the object. We can expose a shift, so we could offset the noise, and we could expose like a random seed, which just allows us to vary the noise. But for now, I'm just going to leave it as the same. But if you want to set those up as variables, then you definitely should do that as well. In order to make this a little bit more interesting, I'm going to create some branches so that we can choose to have noise or choose not to have noise and things like this. So first of all, I'm going to allow us to choose whether we want a displacement. So I'm going to create a branch, and then I'm going to promote this to variable, and I'm going to call it use displacement. So basically all this is saying is, do we want to use a displacement texture? If it's true, then we do. If it's false, then we still want to be able to add noise. So we will add a reroute node, and then we'll connect that up. So it will do the displacement texture and it will do noise. But we also want to choose whether we want to do noise. So we will create another branch. If you hold B and then click in the viewport, then it creates a branch. And then we want that to be on true. So if this is true, we'll put this to variable. We'll name this use noise. And again, we'll align that up. Much like with the displacement, we need to connect this into here because we want it to be, we don't want it to always create noise. We want it to decide whether we want noise or not. And much like displacement, we want to allow for that to be bypassed. Put another reroute node in just to make it a bit neater. Then no matter whether we create displacements or noise, we do want to recompute the normals and tangents because it just makes sure everything's neat and tidy. And then rather than running the target mesh from here, I'm going to break that all the way along to here. I'm going to just drop in the target mesh variable so that it's now all connected up. Next, I need to expose these variables. I'm going to create a new category called noise. Put in the use noise at the top. So basically the boolean will be at the top, so we choose whether we use noise or not. And I'm going to do the same for displacement. So I'll just expand that tab, and then I'm going to drop this in at the top. So now you can choose to use displacement or use noise or use both. So I think that's quite interesting. I'm going to compile. I'm going to select each of the variables and set them to false. So by default, they won't do noise or displacement. This just is the default value. So it just means that when you drop the blueprint into the world, it will default as off. And you can make that on if you prefer, but I prefer it to be off. And I'm going to compile that, and then I will try it in the scene. So I'm going to go to my snow generator, and I'm going to generate my mesh cache because I've obviously recompiled. Now we have the option to use displacement or use noise. So I'm going to turn use noise on. Oh, that actually reminds me of something. Let's go back in and edit a few things. So when we looked at our blueprint there, all these values are the same. So like the base layer is 5 and 0.25, 5.25, 5.25. We don't really want that. We want the base layer to be larger undulations, the mid layer to be sort of medium undulations, and then the top layer to be sort of very noisy, small undulations, high frequency. So like low frequency, medium frequency, and high frequency. So in order to do that, much like we did with the booleans, we just have to give them default values. So intensity wise, I don't think they should be much more than 1 by default. With frequency, the lower the number, larger the noise will be, so it'll look more like gradual lumps. So for the base layer, which we want to be like more gradual lumps, we will make this a lower value. So maybe about 0.25, something like that, maybe 0.5. That will just mean that it gives us quite a nice undulation. So for the mid layer noise intensity, I'm going to set it to like 0.5, and I'm going to set the frequency to also to something like 0.5. And then for the top layer intensity, I'm going to set the intensity to 0.3. And I'm going to set the frequency to something a bit larger, maybe like 2 or 4. I'm not sure which one will be better. Okay, let's go with 3 in the middle. Now we've set our defaults up. If we compile and then close this and go back to generate our mesh cache, turn on our noise, you can see these values have updated now. Then we can generate our snow. I'll come back when that's finished. Okay, that's the model finished generating. Now if we go down to our surface, we can actually see what this is doing. In order to make this a little bit more clear, I'm going to go into my snow material and I'm just going to turn the normal map off. So all we're seeing now is the noise. So you can see that you can get, it doesn't look as good as using a displacement texture for sure. And for sure we could do much more with the noise values and improve them vastly. But what it does do is creates quite a nice little sort of rough silhouette on the model. Basically I'll position myself here and then I'll go into the snow generator and I will turn off the noise and I'll regenerate and show you what it looks like without the noise. Yeah, so now you can see the snow without the noise at all. Now, of course, like anything in this sort of in tools or like procedural generation, in order to get good results, you need to play around with the various values and options that are available. These are just some really quick default settings. The images on my Artstation is using all the same settings that you can see here. It's just obviously I spent more time trying to find values that work for the different models that I generated the snow for. So that's almost everything for this particular video. It's getting pretty long. I think it's well over an hour now. The only thing I really wanted to discuss at the very end was obviously every tool is only as good as you set up the settings. There is loads that you could do to this to expand on. This is just like the sort of bare minimum really. I think, with a bit more time, I've got another version that has more features in it that I added. The shots that are on Artstation and stuff are pretty much exactly the same as this version, but I improved it after that. Added a couple of features like the ability to have snow build up around the base of things. And as I said at the beginning, I probably will do another video. One, I'll be able to do a video on how to make it even more quick to use by adding in a few extra custom events for different parts, so you can maybe edit different pieces at different times, allowing for it to be faster to process rather than you having to regenerate basically the whole mesh each time you change a value. So that's something that I could cover later. Just to quickly finish up on the script, I did a couple of things. I renamed a few of the variables and the categories. I like to number things like 00, 01, 02, 03 in terms of like how you'd work. So generally you'd start by working in the snow, and then once you were happy with the snow, you would move on to the remesh values. And then once you're happy with that, you would either do displacement or noise or both. So that's why I organize it like that. Again, you could have subcategories. If you don't know how to do subcategory, basically if you put the vertical stroke, which is next to shift on the keyboard, and then type something else, like let's say mesh, then what it'll do is create a subcategory. So like under snow, we now have a mesh category, and then compile, and then go to your script. What you'll see is now inside snow, you have another category which is called mesh. Again, in other blueprints, these are normally at the top, which is I prefer personally, but in this it seems to put them at the bottom. So yeah, it allows you to better organize. If you don't want it to keep that category, then you can literally just drag it back into the snow and then it will remove the category that you added. So I just wanted to finish this video with a quick way of being able to convert your geometry script into an actual static mesh that then you can clone throughout a level or whatever. There's loads of different ways to do this, and in this method I'm not going to show you how to do it in script. I'm actually going to show you how to do it using the modeling tools, but it's totally feasible to do it in script. And as I say, if I do another video about some additional features for this, if it's, if people want to see it, then I'll add a bit that shows how to create a script that will have a button that allows you to convert this into a static mesh. But the method I'll show you is really easy. So if you go to modeling tools and then make sure you've selected your geometry script mesh, and then if you scroll down inside the transform, there is a convert option. If you click this, it'll open up a window like this. When it opens on yours, it will probably default to the auto-generated folder. I personally don't use these. I prefer to choose current folder. Now what that means is if I have a content browser, wherever I have selected is where the mesh will be saved to. So basically all you need to do is select the folder, click in the window, choose current folder, and then all you need to do is click accept. This process will take a little while, so I'll come back when it's finished. So that's finished processing now. If you hover over the asset, you can get some statistics, like it's 5 million triangles, which, considering it generated in about 20 to 25 seconds, it's quite impressive how quick Unreal is actually processing the geometry. So then you can open that up, and then you can use this like any normal asset. You can turn on Nanite, you can generate LODs, you can do anything that you'd normally be able to do in here. One thing I will say, obviously at the moment it is 5 million triangles, which is incredibly high amount. Obviously it doesn't need this many triangles. There's like some detail in here, but there's not enough to merit the number that it has. So in the script you could easily add a simplify node, or you could simplify after you've converted it to a static mesh. There's lots of ways. Basically you've got a mesh now and you can do anything that you could do with a normal mesh to this mesh. So that's all for this video. I really hope that you learned something new, and hopefully it wasn't too long and you enjoyed it. Obviously this tool could be massively expanded on and improved upon. This is just the sort of basics. But I recorded a sort of fun stop motion video to highlight some of the features that we've created. So if you want to see that, hang around after the title screen. If you are finding these videos useful, it helps me out if you subscribe. Just means more people might actually see them. Also, if you want to see more of my work, then there's links in the description for Artstation and things like that. Well, thanks very much, and see you in the next video.